Hey guys, and welcome to part 2 in our series of understanding the ECG going from 0 to hero. So if you remember back in part 1, we touched on the idea of how the ECG generally works. So if you missed that, please make sure you watch. And so today in part 2, we will be discussing all about the leads. What are the types of leads? How does it work? So without further ado, let's jump into it. Okay, so we have 12 leads. We know that. And we need to attach these leads to the body. So how do we do that? Well, we use something called electrodes. Electrodes are just tools we use to attach the leads to the body. And so if we have 12 leads, it should be safe to say we should have 12 electrodes, right? Well, no, it's not the case. In reality, we have 10. And so the question is now, how do we get 12 leads to attach to 10 electrodes? Well, let's look into this question. In order to find the answer, we need to look at the 12 leads and what is it made up of. We can do this by splitting it into two groups, bipolar and unipolar leads. And don't worry guys, I will go into the details of this later on. Bipolar consists of 3 leads. Unipolar can be split into augmented and our precordial. Augmented leads also consists of 3 leads, and precordial or chest leads consists of 6 leads. 3 plus 3 plus 6 equals 12, what we originally started off with. So that's fine. So now how do we get 12 leads to fit with our 10 electrodes? Well, there's something you need to know. Augmented leads are not, I repeat, they are not physical leads. However, they are virtual leads. They are virtual leads. Their function is derived from the backbone of our bipolar leads. Again, we will look into this later on. Just gotta trust me for the moment. Augmented leads, I repeat, are not real leads but virtual leads that are built on the backbone of the bipolar leads. So we can then subtract our 3, which will give us 9. Now we have 1 remaining to make our 10 total electrodes. And so where is this remaining 1? Well, it is here in our neutral or our grounding electrode. So plus 1 equals 10. 10 leads for our 10 electrodes. So let's give a calculation here. We have our 6 precordial leads plus the 4 limb leads, including the 1 grounding electrode or grounding lead. And this lead here, guys, you need to know we do not use this. It's not something we use. So we don't use this. Okay? The purpose of this is just to serve as a grounding electrode, a grounding lead. So in reality, we have 10 leads for our 10 electrodes. However, our functioning leads are only 9. Okay, so now let's go into more detail. Bipolar leads. So if we look at the name bipolar, what do we think of? Bi, 2. There's 2 polarities. So our bipolar leads has 2 polarities. Also, what you should know is bipolar leads, the general name of bipolar leads are limb leads. So whenever you hear bipolar leads, just think of limb leads. Alright, and our limb leads have 3, okay, and it's called lead 1, lead 2 and lead 3. So that is convenient. Okay? Bipolar leads have two polarities, meaning bipolar. Bipolar leads are known as limb leads, and we have three limb leads, lead 1, lead 2, and lead 3. Okay? So now let's look into this. So here you can see the three limb leads, lead 1, lead 2, and lead 3. Okay. Now remember what I said about bi meaning 2 and polar. So if we look at lead 1, we see that lead 1 has a negative and a positive pole. Same with lead 2, it has a negative and a positive pole. Lead 3 has a negative and a positive pole. So why do we have these polarities? Well, the simple answer, if you remember back in part 1 of our video, we talked about the fact that the leads, the function of which is to measure the potential difference between 2 points. Okay? And so by having polarity, we are allowing ourselves to have a sort of gradient. And through this gradient, we can observe a change going from A to B, meaning from negative to positive. Okay? So now, this is something I want you to know. When we talk about leads, we are measuring from the negative pole to the positive pole. Always remember, when it comes to our leads, specifically our bipolar leads, we measure going from the negative pole to the positive pole. Just remember that. We measure going from the negative pole to the positive pole. So if this is lead 1, we measure in this direction. So right arm, left arm. Okay? So right arm, left arm. So that's lead 1. So if I draw a figure here, lead 1 would be like this, going from right arm to left arm, and we measure in this general direction. Okay, and let's do the same for lead 2. Lead 2, as you can see, goes from right arm to left leg. So left leg is over here, and we have a negative pole here and a positive pole. As you can see over here, negative pole, positive pole. And let's do the same for lead 3. Lead 3 goes from left arm to left leg. And as you see, we have a negative pole and a positive one. So then, like I said, we measure going from the negative pole to the positive pole. So if we give a sense of direction, a vector, you could say, for lead 1, we measure going from the negative to the positive pole in this direction for lead 1. For lead 2, we measure from the negative to the positive in this direction, and from the negative to the positive in the lead 3 in this direction. Always from the negative to the positive. And so you now may be asking, okay, why do we measure like this? Like what's the reason? What's the purpose? Well, if you understand the physiology of the heart, impulses, if we think of a myocyte, the heart, when it's not contracted, when it's in a non-depolarized state, everything is sort of in a negative state, negative charge. And it makes sense if you understand that the resting membrane potential is in the negatives. Okay, we have a negative resting potential. Then what happens when we have a depolarization? We go positive. Okay, and so when it's positive, and if it's positive, now we have this wave of depolarization. So this is negative, and this wave of depolarization spreads. It spreads, it spreads, it spreads. Okay? So this is the reason why we measure from the negative to the positive pole. The negative to the positive terminal is because it reflects the normal physiology of depolarization in the myocytes. Okay? So that is the general reason. So let's give an example. So bipolar leads, how does it work? So let's assume we have lead 1, and remember lead 1 goes from right arm to left arm. So let's actually write that down. Right arm to left arm. Okay? And now this position the lead 1 is reflects the actual position it would be on a real patient in this horizontal plane. Now let's assign our bipolarity, our negative and our positive pole. Alright, so now let's put this into our table. And so we do the same thing. So this part of the table will be focusing on the direction of the impulse of the heart itself. Okay, so here is the heart, and let's say here is our lead going from our right arm to our left arm. This is lead 1. Now the direction of impulse, let's say we have an impulse generated from the SA node, and our SA node fires an impulse, and the net vector, you could say, travels in the same direction as our lead, going from negative to positive. Let's show that on this table. Here we see the impulse of the heart. This is our impulse going from negative to positive, same as in this diagram. Now the question is, what would be the outcome on the ECG? What sort of deflection will we see on the ECG? Well, the general rule, what you guys need to know, is the following. When a impulse goes towards a positive pole, you have the following. A positive deflection. Alright? If you remember this, you will know the rest. So to repeat, when an impulse from the heart moves into the same direction or moves towards a positive pole, it's a positive deflection. So again, when an impulse moves towards the positive pole, there's a positive deflection. And so alternatively, let's say we have an impulse now moving away from positive. Let's say now we have an impulse here going in this direction, pretty much moving opposite of our lead 1. So like I mentioned, if an impulse moves towards positive, it's a positive deflection. Positive deflection. So now if an impulse moves away from the positive, what do we get? We should get a negative deflection. Okay? So an impulse moving towards positive, positive deflection. An impulse moving away from positive, negative deflection. However, you can find instances in which we neither have the impulse moving towards positive or away from positive. You could have it perpendicular to the lead. Okay. So now let's say we have, let's say, a ventricular depolarization here. And let's say it's in this direction and lead 2 is over here. Negative, positive, lead 2, moving in this direction. But look at the impulse, it's moving perpendicular. Okay, so in perspective of lead 2, would this be a positive or negative deflection? Well, it's not moving towards the positive, which would mean a positive deflection, and it's not moving away from positive towards the negative, meaning negative deflection. It's moving perpendicular. So in essence, what we do is combine the two, making a sinusoidal positive and negative deflection. Alright? So, in general, how does bipolar leads work? It works using the function of bipolarity because it mimics the actual physiological movement of impulses in the heart. And so, when an impulse moves towards positive, there's a positive deflection, as you see here. If it moves away from positive, it's a negative deflection. And if it's perpendicular, it's a sinusoidal wave. Okay. So that was your bipolar leads. And bipolar leads being lead 1, lead 2, and lead 3. So if you understand bipolar, you should therefore get a good understanding about unipolar. Now, unipolar leads, like I said, can be split into two. You have your augmented leads and your precordial leads. So let's look into that. Unipolar leads. Now let's start off with augmented. Now, unipolar leads, as you can see here, means that we have one pole. So this is different from our bipolar leads, which had two poles. So augmented leads, what does it consist of? Well, we term this in ECG terminology as A, and A stands for augmented, and we have three. Augmented, augmented, okay. Okay, so unipolar leads. So, what you need to know about our first group, our augmented leads, is that one, they are termed okay, so unipolar leads. Let's talk about our augmented leads, our first group. So unipolar, what you should know is uni means one. And so these leads only have one pole. We will look into this in a moment. So, augmented leads. You should know that there are three types of augmented leads. One goes to your left arm, one goes to your foot, and one goes to your right arm. Augmented vector left, foot, and right. Alright, now remember what I said about the augmented leads. They are not real leads, they are virtual leads built on the backbone of what? They are built on the backbone of your bipolar leads or limb leads. So they're built on the backbone of our limb leads or bipolar leads. And we can see this here. We can see lead 1, lead 2, and lead 3. They are our bipolar leads. And so I want to actually tell you the idea of unipolarity when it comes to our augmented leads. Now remember what I told you about the bipolar. bipolar has two poles, negative and positive, and we have this in order to have a gradient in which we can measure from A to B. However, here in unipolar, we only have one pole. Now, this makes things a bit tricky because now we don't really have a gradient like we did in our bipolar leads. This, for example, this is our bipolar. But now we don't really have a gradient per se. So we need to create an artificial starting point, an artificial 0 point, let's say. And so the scientists here decided to do this by doing the following. We need to create a central terminal, a central 0 point. So what they did is very simple. They took the midpoint, the mean of each of your bipolar leads. So, for example, lead 1, they took the midpoint here. For lead 2, they took the midpoint here. For lead 3, they took the midpoint here. So these are all situated in the midpoint of each of these leads. Then what did they do? They extended these midpoints to their maximum so that each of these points could form a central terminal. And what do you see here? You see a central crossing, a central terminal. This central terminal acts as our artificial negative point. Okay? So in reality, it's not a negative pole, but it sort of mimics a negative pole. But in reality, it's our central terminal, and this mimics our negative pole. And so by doing this, we can create or mimic what would be our bipolar lead. Okay, so now we have the same function. We can observe a change from point A to point B. So why do we use augmented leads? Well, it gives us 3 new perspectives in 3 new angles. So let's start off with AVL. If we extend, this is our new AVL. Let's do the same for AVF. Let's extend, and this is AVF towards the foot. Okay, now let's extend for AVR. This is AVR going towards your right arm. So here, as you can see, we have made 3 new perspectives on the heart. And like I mentioned, each lead is an eyeball. So now I'm looking at the heart from 3 new perspectives. Okay, so this is the benefit of having augmented leads. Alright, so if I pull an image, what you should see is something like this. Okay, so you can see AVF goes down here, AVR goes up here, and AVL goes up here. So let's put it on the diagram here. Central terminal, AVR goes in this direction, AVL goes in that direction, and AVF goes in this direction. Think of an upside down Mercedes. And then finally your unipolar precordial lead. Now just the same as how the augmented lead works with the central terminal, it's no different for the precordial leads. However, the precordial leads consists of 6, and they are positioned strategically across the chest. V1 is placed in the fourth intercostal space on the right sternal border. V2 is placed on the fourth intercostal space on the left sternal border. V3, we missed that out and we move to V4. V4 is in the fifth intercostal space, mid-clavicular line. V5 is in the same fifth intercostal space in the anterior axillary line. And then V6 is in the same fifth in the mid-axillary line. So once you've placed V2 and V4, V3 goes in between. Alright, you don't have to calculate where to put it, just put it between V2 and V4. Alright, so now we have an idea of the bipolar, the unipolar leads. However, what's the sort of significance behind all of this? Well, we can see this when we combine the leads. So in this image you can see that the leads actually have some spatial function. And why is that the case? Because the heart is not a 2D organ, as you can see here. Alright, it is 3D, as you know. And because it's 3D, we need leads that can basically measure the 3D essence of the heart. Our leads can be split into two. Leads which measure in a vertical plane and leads which measure in a horizontal plane. The leads that measure in a vertical plane measure the 2D essence, sort of the front plane of the heart. These leads are your bipolar or limb leads and your augmented unipolar leads. However, when it comes to horizontal, the horizontal leads measure the 3D essence. And so you can see this in the green over here. Here, these are represented by our precordial leads, and we have 6 of them. They measure in the 3D horizontal plane. By combining these two together, we get a full 3D essence, 2D and 3D overview of the heart, and therefore the impulses in the heart, whether they move in a 2D or 3D direction, in a vertical or horizontal direction. We've got that covered because we have our vertical and horizontal leads. So that is the significance behind the vertical and horizontal leads, our bipolar and unipolar leads. Alright, and now this second picture I would like to briefly explain to you. This image basically is representing each lead with an angle. And the leads I'm talking about here are your vertical leads. Your vertical leads being what? Your bipolar limb leads and your augmented leads. As you can see here, augmented leads and limb leads. Each of these leads has an angle, and why is this important? You will understand this later when we get into the idea of axis. Because leads can help us identify, is the impulse of the heart, is it orientated in a normal axis or a deviated axis? So this is an idea which we will touch on later on. However, just get familiar with the idea that depending on the location of these leads, we can represent this with an angle depending on where it's located in comparison to the midline, as you can see here. This is 0 to 180 midline here. Alright guys, and now to wrap things up, combining the leads, let's actually build the 12 lead from scratch. So let's start off with our bipolar leads, and let's start off with our lead 1 of our limb leads, going from right arm to left arm. That's lead 1. Now from right arm to left foot, that's our lead 2. And then from left arm to left leg, which is our lead 3. Remember, bipolar, it has a negative and a positive pole. Perfect. Now let's get a different color and let's demonstrate the augmented. Remember what we said about augmented, they're unipolar. And so what? They require a central terminal because they don't have the bipolarity, they don't have the negative pole. So let's create an artificial negative. And so we have 3, AVR, AVL, and AVF. Alright, AVR, AVL, AVF. And now we are missing one of our final unipolar leads, which is our precordial. These measure in a horizontal fashion. V1, V2, V3, V4, V5, and V6. V1, V2, V3, V4, V5, and V6. They measure in the horizontal fashion, whereas our limb and augmented measure in a vertical fashion. Now, like I mentioned, guys, each of these leads is a eyeball. They measure, they look at the impulses from 12 different perspectives. Alright, guys, so this is the end of the video. As you can see, in the next video, we will actually translate the idea of perspectives onto the ECG paper, as you see here, because each of these leads has a specific perspective on the heart. As you saw here, okay, it can be translated onto this ECG paper. And so this concludes our second part in our series of understanding ECG going from 0 to hero. I hope you guys enjoyed. Today we discussed the leads, the types of leads, how does it work. In the next video, as you see, we will discuss the trace and how it corresponds to the heart. I hope you guys enjoyed and stay tuned for the next video.